Hello everyone. It's been a while since the last milestone, which is the milestone 2. There was some delay because of the COVID-19 thing, and so e-learnings are postponed and so on. But anyway, in this milestone today, basically we'll be talking about how to assess data we put into MinIO data lake and perform data cleaning on those data. Without further ado, let me bring you to the MinIO data lake that we had from last time. So basically from here, you can really see that there are a bunch of data loaded here. These are all the data that we scrap from the weather data site, and there are about 107 of them, all in CSV format. What we will be using today will be the Python SDK for MinIO. We will be getting the objects in the buckets. So buckets is basically like a folder in a data lake, right? So these are basically ways we can use Python to code, to make buckets, list bucket, remove them, get the objects in the buckets, and so on. And this is the site you want to refer to if you want to perform this sort of operation on Python. Okay, so bringing you to the notebook. First of all, we need to import all the dependencies that we are using for this project, today's project. So we have the normal OS, NumPy, Pandas, the Matplotlib for plotting graphs. And what might be interesting is the sklearn input here, where we're going to use knn input to fill up the missing values. So knn input is basically a k nearest neighbor algorithm where it looks for data that are quite close or quite similar, and then it will basically use those data to infer the missing data. Okay, first of all, for today, we want to assess the data lake from MinIO. Like how we set up for putting the data into MinIO. Basically, we need to use the syntax. We import the MinIO library. We set up the MinIO client by calling this MinIO class. So you need to put in the IP address, the access key, and secret key. Sorry. And basically, this MinIO client.list objects will basically list all the objects inside this bucket, where we have one here called weather data, and save it as a generator under objects. It will return a generator basically. So for example, just to print out the 6 files in the bucket, you can see it shows the 6 files name here. And if you look back in the browser for MinIO, it's also the top 6 files here. Yeah. So it's basically mean that we have been able to access the MinIO remotely. If you do not remember, this MinIO is basically set up on a Amazon EC2 instance, so it's remote. It's not on a local host or anything. But of course, you can set up as a standalone in your local host system as well. Okay, another thing I want to bring attention to you is the Amazon Web Service SDK, Portal 3. This is the Python SDK where you can use it to query data from the S3 data storage system using like SQL and so on. So for just demonstrating it, I will be showing you how we perform like a simple SQL statement from S3 data storage. So here what we have is an SQL statement where I say select the day and then the location and then T for temperature from a S3 object, which is the table, where the temperature is more than 20 degrees. So this is just a syntax you have to understand or remember when you're using this SDK. There are resources where you can Google and basically look at the documentations, and you'll be able to start in no time. Yeah. But just as a simple simple way of showing you how the SQL work. You have it here, where we say S3 select object content, we put the name for the bucket, we put the file name, and we say we want to use SQL here. And the expression is the SQL statement we have here. We say that the input serialization is CSV because the file is in CSV, and we want to output it to CSV format as well because we want to read it using Panda. So then R basically is like a dictionary format where if it's successful reading the file, it will give you a payload, and in the event you can basically append all these results, and it will be in a byte string format. So what you do is basically you want to decode them and read it using Panda's read CSV. So these are all just syntax you need to be familiar with. So if we run it here, I haven't declared this. If we run it here, you can see it has performed the SQL statement here, where it has taken out the days column, the location column, and the temperature columns for anything that is more than 20 degrees for the temperature. So you can see here there's basically everything is above 20, and if we look here, there's basically everything is more than 20 degrees. Alright, so this is just something good to know. For our purpose here today, we won't be using this Bottle 3. We will be mainly using the MinIO SDK to just basically get the CSV file in general and perform the data cleaning from those files. So to do that, we use the getObject method for MinIO, and we list the bucket name, and then we can put the file name here, and basically it will return the object just like reading a file from a local directory. And then what you can do is basically just do whatever you need, like reading a CSV using Pandas, so you can get the data frame easily. Alright, but since we have 107 files, we're not going to do this one by one, but we're going to put it in a loop where we say, okay, I do not want to get object, but instead I want to list all the objects. I want to get all their names so that I can perform it in the loop where I say I want to get the object in this bucket and put the object names from the list of object names that has been returned. Okay, then I will read these CSV objects and I append it in the list for me to be able to concat them in the future. So if we run this, you can see it's going through all the files. There are 107 of them, but this should be quick. So we are done with Indonesia's. Now it's Malaysia, and I think we are pretty much done. Okay, so that was done, and to show you an example of the file in the first data frame list, this is basically the format of the CSV that are inside MinIO. You can see there are multiple columns here: the country, location, station ID, latitude, longitude, day. These are all very self-explanatory. What might not be so clear is like a T, a TM, TM, SLP, H, and so on. So I have actually declared a data dictionary here, where you can see for the different variables, these are the descriptions. Okay, so the main data that are of concern here are basically anything that can affect the growth of palm tree and what will affect the yield of like the palm tree fruits production, right? So we would pay attention to maybe the average temperature or the maximum temperature. What might be even more important will be the total rainfall, because for a palm tree to do well, you cannot have too much rain, or you do not want to have like a drought sort of weather where it does not get enough water. Okay, so yeah, these are just a bunch of attributes we'll go through. There are things like snow indicator, which would not be applicable at all for our data set. So then there are plenty of data cleaning we need to do for this data set, because as you can see here, some of the missing values here are basically just empty values, but some of the missing values here are basically in form of dashes. So these are things that have to be taken care. But to be able to do them all at once without just looping through files, we want to aggregate all the data into a single big data frame, which is what I'm doing here. I use the panda concate function, and with the data frames in the list, I concate them again. I concate them using axis equal to 0, which means that I want to stack them row by row on top of each other, the data frame, and basically reset the index to make them all from 0 to 1. I mean from 0 incremental to the last value. So if you look at this, we have 385,000 entries, and it doesn't show you that there is any missing values at all, but we know there are missing values. So we will need to convert all these the column type accordingly. The memory usage is only 60 megabytes. It's not too much of an issue. So first of all, we want to drop data that have all null attributes. What I mean here is basically, if let's say the data is missing consistently from the day to all the way to here, if the whole row is basically missing, I want to remove it because I know for sure it's useless. So that's what I'm doing here. So the function here is basically saying from column index 3 to the end, I want to know what is NA. If it's NA, we return true. And if all of them are NA for that row, it will return true as well. And so when I say df with this curly thing for this index on now, it will return me a df data frame that is without all these null values. And the next thing we want to do is basically to set the correct type and standardize all the attribute values. So if we look back here, things like this 0 and 0, these are indicators. Like it indicates whether they are storm, or in the case of FG, it indicates whether there was a fog, right? So preferably, we want this to be in terms of Boolean, true or false, or 0 and 1. And that will be what we will be doing here. So for these columns, RA, SN, TS, and FG, anything with 0, O, we will make it true. If it's empty or not O, we'll make it false. So here what we use is basically looping through the column of the data frame. We apply a function using lambda where you return x equal, you check if x equal to 0, if it's equals to O. If it's O, then we return true. And what we will get here is basically for the last 4 columns, for these 4 columns we set up, it will have these true and false values now instead of O and missing values. Also, the next thing is we want to convert all these dashes into NA, because dashes is not very readable for us because it's in string. We want it to be something that the code understand, which is NA for missing values. So the same thing we do is basically applying the sort of logic where we say if x is equal to dashes, return none, and the NA value. So we can see everything here is changed to NA. And now that the missing values are basically sort of taken care of, because this is applied to the entire data frame, where you can see something like in PP here, which with dash is also converted to NA now. So all the NA values is basically taken care of for the data frame. So with that done, we want to convert all the file types for T, TM, TM, SLP, all this into a float type, which is what we are doing here. We basically do a loop for the columns, and we change the type using S type float, and so that will change everything to float type for our data. And if we try to look at the info, you can see everything here is basically float, and the last 4 is boolean, as we have changed it earlier. So the day here is still an object. We will change it to a datetime object as well. So to do that, we use the panda to datetime. We set the format based on what was in the data. Like here is day, month, and then year. We just basically put the format in, because then it knows what to expect and it will do it much faster. So once we have done that, we look at the data again. You can see that the format has changed, but this is because it's now in pandas datetime format. Alright, so the columns like country, location, and station IDs, we want to also change them as categorical data. What we do is basically looping through columns again and set them as category. Now that we are done with all the setting up the types, handling the missing values to standardize them, we will get a summary statistic of the data numerical attributes by doing a quick describe. And from here we can see, like for these data here, we can see like easily the mean temperature for this region, Indonesia, Malaysia, and Singapore, around 27 degrees Celsius, which is quite reasonable. The maximum is 32.9. This is not too far off as well. So the data are good. There are not too much outliers. I don't think there are any outliers at all. Yeah, these are all pretty reasonable values. Yep. So the next thing we're going to do is to handle the missing data. First, we need to know how many percent of missing data are in each column. So then what we do here, we do a quick check for missing values using the isNA method again. And here I have plotted out a graph for each attribute and their missing percentage of missing values. So VG here have almost 100% of missing values. We know for sure it won't be any good if we keep this column, so this will be removed. The SLP here is pretty high as well, around almost 20%. And then if we look here in the dictionary, it's for the atmospheric pressure at sea level. So I do not think that will be very useful in terms of predicting the yield of the palm oil trees. So it should be okay to just remove it. Now we move forward to PP, which stands for total rainfall and snow melt, which we know there won't be any snow melt, so it's just rainfall. In this case, it's very important that we have the values for PP. We have to keep the PP, the rainfall attributes here, because this will be a major attribute that would affect the palm oil yield. So then we need to figure out a way to fill up all these missing values smartly. Yeah, and everything else is reasonable. We can just do a simple mean input, or the earlier version we mentioned earlier, the KNN input as well. Alright, so as discussed just now, we will just simply remove VG and SLP from the data. So that will be done. And if you look here, what? Oh, my bad. The data has been removed, so I'm not going to show you. Yeah. So if we look here, VG and SLP is not in the data anymore because we use the function called drop. Alright. So now we have everything pretty much in place except for the missing values in all the rest of this column. What we want to do is doing a KNN imputation or a median imputation. Actually, this is wrong. I will change it to KNN. Okay. So what we have here, we need to know all the NA values, and also basically we're setting up them. We want to group them by station ID because we want to impute them according to location, so that when we impute it, we are only imputing using values of a location rather than using values from a faraway location. Like, let's say if you have something in the north of Malaysia, you don't want to impute missing values in that location from data that are from the Borneo side of Indonesia, right? So that is what I'm basically doing. I'm grouping them by the location and then doing an imputation based on the subset of a location, the data in the location. So this will take some time to impute. Okay, it's not that long. So then if we look back at the data and compare it to the data we have earlier, if you look at the fifth row, the one on January 4th, is actually now being filled up with a value of 3.209, which I think is okay. So once all these imputations are done, we basically call it good. This data is clean. We might need to do some verification later on, but that will be for later time. So now to save our progress, we basically want to just quickly save them as a CSV into a location of desired. You can also save it into MinIO, no problem. But here I'm just saving in a directory. Alright, that's all for this. Have fun. See you next time.